Okay, so proof of the second kinematic equation, the one that's like the box equals box. There we go. So you want to start off with, this is what you were given, change in position over change in time equals, this is your velocity. Remember, we put a bar on top for average velocity, equals, okay, this is just like you average your grades. Final velocity plus initial velocity over 2. Now, if you look, these are both equal to your velocity, your average velocity. So we can just get rid of that. I'm going to put this, therefore, I'm going to go across. Change in position over change in time is equal to final velocity plus initial velocity. Okay, I'm going to go and put these in parentheses just to kind of group them, make it easier down the line, over 2. Now, what you can do with this, if you notice, you've got delta x, or I shouldn't say delta x, change in position. That's just your displacement. Actually, you know what? Forget that. I'm going to write this down here. That's just, therefore, your change in edge, delta x, change in position, it's going to actually be your displacement. It's at the top of your sheet. Okay, in this change in time, that's time final minus time initial. If you recall, your initial time is just 0, so we just really have one time. So it's going to be displacement over time. Okay, that is going to equal, once again, the parentheses, velocity final minus, plus, like your grades, add them, then divide by 2, velocity initial. Okay, and that's going to be over 2. All right, so at this point, let's get rid of everything in the denominator, the bottom. Okay, so what I'm going to do is let's get rid of the 2 first. So 2, cross that out. What you do to one side, you do to the other. 2, it stays here. Okay, while I'm over here, I might as well get rid of the t. Okay, so what you do to one side, you do to the other. All right, I'm going to go across this way. Therefore, you have 2 times displacement equals velocity final plus velocity initial okay, and all that's times time. And this is as far as you can go with this one portion. Now, what you would want to do next, let's see, go use purple. Okay, if you recall, you have acceleration equals change in velocity over change in time. Okay, that's really just going to be velocity final minus velocity initial, the arrows, over time final minus time initial. This is the same deal as before. That goes away. So basically, therefore, you have, on this, you have acceleration. Very good, acceleration. Acceleration equals, I'm going to put these in parentheses too, velocity final minus velocity initial. Okay, all over time. Now let's solve this for time. Okay, so therefore, you have, well, Actually, let's just look at this. Let's go time right here. And let's do that. And I'll do that in another color. Time. And go time times acceleration. Just multiplying it. I should have done this, but I kind of ran out of space. So therefore, you have basically acceleration times time equals velocity final minus velocity initial. Okay, and look, I'm just going to get rid of this acceleration. I'm just going to not even worry with the railroad track thing. I'm just going to put that over acceleration. Essentially, anytime you have something like this, these two will switch places. Hopefully you know that from algebra, though. Okay, so you have this. So look, this is just time right around in here. I'm just going to plug this in right up here for this time. So that's going to give you, do this in gray, you're going to have 2 times displacement, okay, equal to velocity final plus velocity initial. Okay, just going to multiply all of this by, remember we're going to substitute this in for time, velocity final minus velocity initial. Okay, over acceleration. Now, hopefully you remember FOIL. That's kind of why I'm doing this in gray. First, you got velocity final squared. Okay, and let's look at this. See how we have the same thing? We're going to get velocity initial and times velocity final, or velocity final times velocity initial negative, and velocity final and velocity initial positive. Basically, when you have two exact same things, and you got a plus and a minus, I'm sure you already know this, you don't have any center term. They cancel each other out. So we're just going to have the two last ones. So you're going to have minus velocity initial squared. That's a square. Okay, all that's over acceleration. Okay, and recall, this is equal to 2 times displacement. So here, I'll just, again, put that equal to 2 times displacement. Hey, look, all I have to do at this point is have another color. Go back to red. Okay. Multiply all this times acceleration. Acceleration goes away. Hey, this times acceleration too. It's kind of out of order. So what you're going to get is velocity final squared minus velocity initial squared equals 2 times acceleration times displacement. And what I'm going to do at this point is let you put this in the correct form, because if you turn it in like this, I will know that you just kind of went through and did this. This is not the exact right one. It's very, very, very close. You need to do one little thing concerning this, so I'm not going to box it because it's not the correct answer, but I'll let you figure that out. Okay.